In my last presentation, Easter Egg Hunt in the Laramie Mountains, we covered the near-perfect cross of canyons made by two out-of-phase circuits coming together. This time in the cross from Laramie, we'll look at the wind-cut valleys around the cross that resulted from induced winds. Many viewers will recall Michael Steinbacher. He theorized landscapes formed by electric winds that prevented deposition of dust raining from the sky. He even performed experiments that demonstrated electric winds doing it. What I'm going to show you is exactly what he was talking about. Wind-cut channels are sometimes narrow, straight, and deep, like the capacitive winds shown in this figure. And sometimes they snake, divide, and join, following induction currents, cutting broad valleys with funnel-shaped inflows, as shown in these figures. Winds in the northeast quadrant flowed parallel to the southeast quadrant winds, and both cut perpendicular to magnetic field lines. But the northeast winds shoot inside the loop of magnetic field lines to the apex, where the southeast winds cut across the loop sideways. In the northwest quadrant, winds followed magnetic field lines, making a sharp bend at the crux of the X, and staying inside the quadrant, but lifting as they made the turn. The southwest quadrant wind has a split personality. In one half, winds flow straight at the crux of the X in direct opposition to the winds from the northeast quadrant. These winds met in a central updraft that lifted them vertical. In the other half of the quadrant, winds circulate, making an S-shaped pattern that begins parallel to and then crosses magnetic field lines perpendicularly. The reason for the winds to flow either parallel to or perpendicular to magnetic field lines is induction. Both moving magnetic fields and electric fields induce current. Reactive current is called capacitive when it follows electric fields. It's called inductive when it follows magnetic fields. Magnetic fields are perpendicular to electric fields in certain conditions. And since these mountains form from circuits 180 degrees out of phase, things tend to line up. The Laramie circuit produced induction currents following both electric and magnetic fields. Winds in the northeast quadrant were due to capacitive reactance following the electric field, while winds in the northwest quadrant were due to inductive reactance aligned with magnetic field lines. The southwest and southeast quadrant winds were combinations of capacitive and inductive currents, but expressed in different geometries between the two quadrants. Reactive currents express either inductive or capacitive behavior, or a mix in different parts of a circuit. Therefore, it's not surprising the southern quadrants have blended circuits. What is surprising is how clear the pattern is etched, in spite of all the chaos and violence of this event. On display are electromagnetic forces that stirred the earth like we would stir iron filings with a magnet. Further away from the discharge, the southern quadrants mixed into a large tornado with two satellite whirlwinds that lifted wind in this quadrant into the mesocyclone storm. This tornado region sits just south of the X, which marks the center of the mesocyclone's central updraft. This position corresponds well with the formation of wall clouds that spawn tornadoes in typical thunderstorms. Shock waves reverberated absolutely everywhere, creating nearly vertically oriented tetrahedrons layered like fish scales. Shock waves from winds sucking into the maelstrom left triangular waveforms where separation bubbles form beneath screaming jet stream winds. They display the direction of winds that confirms the wind paths that I'm describing. Where wind exceeds supersonic speed and is forced to change direction, shock waves form. They are like folds in the fabric of the wind, which is stiffened into laminar jet streams segregated by extreme pressure differentials. Tornadoes draw ground winds from all directions, but in a supersonic tornado, there's an inlet zone where the majority of wind enters the rotation. They are drawn from ambient jet stream winds that the tornado forms tangent to. The next figure shows winds entering the whirlwind change direction from linear to rotation, forming a large shock wave tangent to the rotation and parallel to the jet stream, shown in Note 1. This inflow shock wave is a distinct feature of tornado footprints if the winds involved were supersonic. If the winds also rotated at supersonic speed, additional shock waves form tangent to the rotation at points of shear between the rotating winds and ambient winds. Finally, tornadoes may form shock waves due to shearing interior to the rotation, where they curl inside the inlet zone. The largest tornado lies in the southeast quadrant and produced Laramie Peak. It's the highest point in the range at 10,260 feet and sits next to a gouged-out valley that dips to 6,700 foot elevation. Both the valley and peak are within the tornado's rotation. Tornadoes form a cambered debris bowl where the winds scrape the ground, and the debris is lifted away where the force of inlet winds carve at the land, and then are deposited on the opposite side of the rotation as the winds lift. Mount Laramie is one such deposit. Shock waves are evident where supersonic winds change direction. Tetrahedrons formed in the northeast quadrant, where winds following the electric field lifted to create separation bubbles. They form tetrahedrons in linear rows conventionally known as monoclines, but they are in fact supersonic sand dunes. This is especially evident if you examine the breaks and inflections caused by constructive and destructive interference patterns in the mountains. Tetrahedrons formed by jet stream winds rising to the mesocyclone in Area 1, and a new set of tetrahedral dunes formed in Area 2, which deflected winds and starved Area 3, leaving a triangular interference zone that pinched out formation of tetrahedrons from the shock wave of Area 1. The gap between Areas 1 and 2 turned the wind and formed a tornado in its eddy, which is shown in Area 4. This figure shows these same features from another angle and how eddy currents form behind tetrahedrons in a low-pressure zone beneath the rising winds. These are, in effect, destructive interference troughs behind the constructive peak of the wave pattern as winds undulate across the ground. Now, stepping back to look at the entire heart-shaped circuit domain, blue lines trace the ground-level jet stream winds. Violet swirls indicate where tornadoes made definitive features on the ground. Red X's are discharge patterns, and the green areas are where the thunderstorms downdrafted to the rear and rear flank of the storm. The two lakes are where the circuits connected to ground deep in the earth, leaving a distinct V-shaped landform between them, forming the base of the heart. The top of the heart is an accumulation of positively charged matter swept there by winds inflowing to mesocyclone updrafts, and the bottom of the heart is a negatively charged basin swept clear by downdrafting winds. These are the anodic and cathodic sides of the domain, neatly separating the top and bottom of the heart. There are several other symmetries and heart analogies hidden in the Laramie Mountains. This would have been a horrible place. The discharges blasted negative ions and free electrons away in arc blasts, while drawing positive ions inward. The velocities, temperatures, and densities of the winds differed. Their dielectric properties differed. Their charge densities differed, and they segregated. Positive inflow hugging the ground, accumulating dust that adhered to the statically charged land. The drag of the winds covered the land with blankets of dust, layered like fish scales, hardened by sonic pressure and electric currents that snapped and crackled everywhere. The clouds roiled in whirling updrafts overhead. A squall line of heavy thunderstorms formed in mirror image to the chaos on the ground, spitting lightning in carpet bomb fashion that would have made the clouds glow. Rain fell in torrents of mud and rock. Supersonic winds scoured the ground, inflowing to biblical whirlwinds, and sonic shock waves reverberated in electrified sheets of plasma current. The entire atmosphere surrounding the storm patterned in the shock diamond herringbone of flashing, ionized shock waves. Lightning discharge blossomed like acne, leaving pinnacles, dikes, craters, and domes in regions of high tension. Winds stirred around these discharges, disturbing the ambient winds into transient cyclones that left hardened dunes as monuments. and the winds reached supersonic speeds, patterned by shockwaves that embossed the land with triangular and polygonal waveforms. At the time they were made, with all the violent turbulence, heat, and electric current, the mountains likely resembled not so much hard granite, but puddles of hot jam, squished into form by wind and mashed by an electric fork. This whole mountain range is direct and unequivocal evidence of electric formation. Conventional means of uplift, faulting, and erosion, requiring several eons of disconnected events, could not by any reasonably statistical probability produce phase diagrams 15 miles across the face of the Earth with induced current paths shaped by magnetic fields. The features of these mountains are coherent only when recognized as the result of electrical circuits in the Earth. Each ridgeline and canyon, every hill and dale, can be tied to a sequence of events that occurred at one particular phase in Earth's evolution, involving extreme electrical stress on the planet. Conventional science can't explain why any two of these features coexist, let alone demonstrate their disjointed theories empirically or model them with any plausibility on computers. But you can make discharge patterns like this with some wire and an AC power source. Or as I have done, bring two out-of-phase plasma balls into contact. I simply powered one plasma ball with AC current and one with DC, so it produced an in-phase, out-of-phase sequence as the AC side alternated. Between the two balls, the sparks joined and spread with each pulse, like hands clasping, then spreading fingers to push away as energy expended in reactive discharges, perpendicular to the in-phase current flow, just like the X patterns in the mountains. The plasma interaction between the balls didn't occur at the glass barrier of the globes, as you might expect. It occurred inside the DC ball with the weaker voltage, pushed there by the higher voltage AC ball. Unfortunately, the experiment fried my plasma balls before I could film it. I don't have the right kind of high-speed equipment needed to properly photograph it anyway. But this image shows the effect, although I don't know the circuitry of this exact setup. The Tesla coil discharging to an electrode. White filaments of current direct connect to the electrode, while violet plasma flames of reactive power shoot outward in a cone around the discharge. The angle of the cone isn't 90 degrees, but that's an artifact of this particular circuit in its phase angle. The Laramie circuit resulted in a discharge along a dipolar alignment between circuit domains, with a capacitive reaction aimed 90 degrees clockwise from the polar alignment, and an inductive reaction 90 degrees counterclockwise, forming a cross, because the domains were exactly 180 degrees out of phase. So you see the world as a more understandable place than you've been led to believe. To understand it, we need to recognize the Earth contains holographic imagery of its past charge distributions. We need to recognize that charge distributions result from circuitry that can be traced, understood, and put to experiment and modeling. The information is there to learn vastly more than we know today about Earth's creation. To get the info, we just need to ask the right questions.